Okay, I want to find the integral of x over x plus 1 times x plus 3. So before I start doing anything with integrals, I'm going to rewrite that fraction using partial fraction decomposition. So for each unique linear factor, and I have 2 of them, I need a constant over each one. Okay, and then I'm going to multiply both sides of the equation by x plus 1 times x plus 3. So multiply this by x plus 1 times x plus 3, and multiply this side by x plus 1 times x plus 3. So on the left, everything, the denominator cancels, and I just get x. Okay, on the right, when I distribute the x plus 1 times x plus 3 to the a fraction, the x plus 1's cancel. So I have a times x plus 3. When I distribute the common denominator to the b fraction, the x plus 3's cancel, and I have b times x plus 1. All right, in the demo, we chose 2 random values of x to build 2 equations and 2 unknowns, because this has to be true for every value of x. Now I'm going to very smartly choose some values of x. Let's let x be -3. You'll see why I chose -3 as soon as we plug it in. So the left-hand side, I have -3 equals a times -3 plus 3. Oh, that's why. Plus b times -3 plus 1 is -2. -3 plus 3 is 0. Right? A times 0 is 0. So I get -3 equals -2b. So b is 3/2, or 1.5. And then for my other value of x, we should choose a value that will make this parentheses become 0. So maybe x equals -1. So I have -1 equals -1 times 3 is 2. So 2a plus 0b. And so a is going to be -1/2. Now I'm going to go back to my integral and rewrite the integrand as the sum of 2 fractions. So this is going to become the integral of a over x plus 1, where a was -1/2. -1/2 over x plus 1 plus b over x plus 3, and b is 1.5. 3/2 over x plus 3 dx. So all I've done so far is rewrite the fraction as the sum of 2 fractions using partial fraction decomposition. Now I'm going to take an integral of each term separately. So this becomes -1/2, the integral of 1 over x plus 1 dx, plus 3/2, the integral of 1 over x plus 3 dx. So this is -1/2, the ln of x plus 1, plus 3/2, the ln of x plus 3 plus c. Okay, I want to set up a partial fraction decomposition for this fraction, but I don't have to solve it, thank goodness. Okay, so I have x to the 4th minus 2x cubed plus x all over, at least they factored the denominator for me, x minus 2 times x plus 4 cubed times x squared plus 9. So I have 3 different kind of factors in my denominator. I have a unique linear factor, a repeated linear factor, and an irreducible quadratic. Each of those contributes something different to the partial fraction decomposition. So the unique linear factor, which is the most common thing you're going to run into when you're doing these kinds of problems, you just put a constant over the linear factor. For a repeated linear factor, you have to put a constant over the linear factor, plus a constant over the linear factor squared, plus a constant over the linear factor cubed. And you would keep doing that until you hit whatever the exponent is on that linear factor. And then for the irreducible quadratic, you have a fraction with the irreducible quadratic as the denominator and a linear factor on top, ex plus f. Okay. I want to find an integral of 2x squared plus 4x minus 9 over x cubed plus x dx. And my first hint is to break up the fraction. So I'm going to factor the denominator, 2x squared plus 4x minus 9 over, factor out the GCF, and I get x times x squared plus 1. So I have a unique linear factor, x. That's why I have an a over x in the decomposition. And then I have an irreducible quadratic x squared plus 1. So that's why I have a linear term over the x squared plus 1. Okay, so I'm going to set this up. I have 2x squared plus 4x minus 9 over x times x squared plus 1. And I need to break this into a over x plus bx plus c over x squared plus 1. So I multiply both sides by the common denominator, x times x squared plus 1. Okay, so on the left, the whole denominator cancels, and I have 2x squared plus 4x minus 9. And on the right, when I distribute my common denominator to the a fraction, the x's cancel, and I have a times x squared plus 1. And then when I distribute my common denominator to the second fraction, the x squareds plus 1's cancel, and I get x times bx plus c. So I've got no more denominators. Step 2, I need to pick 3 values of x because I have 3 unknowns, a, b, and c. And so one nice choice for x is x equals 0. So let's start with that. If x equals 0, I get negative 9 equals a. And then the next term goes away because x is 0. So, oh, that's nice. I know what a is right away. All right, so let's pick another one. X equals 1. And now I know what a is, so I'm going to put that in my next equation here. So if x is 1, I get 2 plus 4 is 6 minus 9 is negative 3 is equal to, a is negative 9, so I have negative 9 here, times 1 squared plus 1 is 2, plus 1 times b plus c. So to simplify this a little bit, this is negative 18. I'm going to add it to both sides, so I get 15 equals b plus c. And now I'm going to do one more value of x. Maybe I'll do x equals negative 1. Okay, so if I put a negative 1 in here, I get 2 minus 4 is negative 2 minus 9 is negative 11. And then I know the value of a is negative 9. Negative 1 squared is 1 plus 1 is 2. And then I have minus 1 times b. B times negative 1 is negative b plus c. So I simplify this a little bit. Negative 18, I'm going to get 7 equals b minus c. All right, so that worked out nicely because I have a plus c and a minus c. I did not plan that, I swear. Add these two equations together. 15 and 7 is 22. B plus b is 2b. And positive c and negative c is 0. So now I can divide both sides by 2 here, and I get b is 11. And then pick any other equation to solve for the c. So let's see, 15 equals 11 plus c, so c has to be 4. So I have my 3 values of a, b, and c. So I can go back up here and I can replace them, a, b, and c, with the numbers. And then I still have to break up bx plus c, but I'm going to do that next. Okay, so I'm going to go on to a new page. And just going to copy this. Okay, so I just copied my partial fraction decomposition, and now I'm going to replace my a, b, and c with the values I found. So a was -9, b was 11, and c was 4. Just double check. -9, 11, and 4. -9, 11, and 4. Okay, good. All right, so that's what I want to integrate. So now what I'm trying to integrate is the integral of -9 over x plus 11x plus 4 over x squared plus 1 dx. Break this into 2 separate fractions, or 2 separate integrals. So I get -9 times the integral of 1 over x dx plus the integral of 11x plus 4 over x squared plus 1 dx. All right, so for this one, that's what the third hint was for. Let's go back and read that third hint. Break bx plus c over x squared plus 1 into 2 fractions that have the same denominator. Bx over x squared plus 1 plus c over x squared plus 1, unadding these 2 fractions. Okay, so I have -9 times the integral of 1 over x dx plus 11x over x squared plus 1 plus 4 over x squared plus 1 dx. All right, so this first one is just ln x. So this becomes -9 ln x plus. This one I'm going to evaluate with a u sub, right? Because I see x squared in the denominator with an x in the numerator. And then this last one is just 4 times arctan. Okay, so to get this one in the middle, I have to do a quick u sub. So I'll go over to the side here and do that. So I get u is x squared plus 1, which means du is 2x dx, which means that dx is du over 2x. So this is the integral of 11x over u times du over 2x. The x's cancel. So I have 11 halves, the integral of 1 over u du, which is 11 halves times the ln of u, which is x squared plus 1 plus c. So that's what is missing in the middle here. So this is 11 halves ln of x squared plus 1. And I have the plus c on the end there. Okay, last problem in the activities. The integral of x squared over x minus 3 times x minus 1 times x plus 2. We start by just working on the partial fraction decomposition. No integrals at all. Just trying to rewrite this fraction as a partial fraction decomposition. I have 3 unique linear factors, so it's just going to be a constant over each one. Multiply both sides by the common denominator, and I get x squared equals a times x minus 1 times x plus 2 plus b times x minus 3 times x plus 2 plus c times x minus 3 times x minus 1. Okay, I have 3 unknowns. I need 3 equations. I'm going to try to smartly choose values of x to plug in here to get my equations. I think I'm going to choose x equals 1 because then x minus 1s will become 0. So that'll become 0 and that'll become 0. I'm going to choose x equals 3 because then my factors of x minus 3 will become 0. And I'll choose x equals negative 2. X plus 2 factors will become 0. All right, so when x equals 1, I get 1 equals, my first term goes away. My second term is b times x is 1, so negative 2 times 3. And then my third term goes away. When x equals 3, I get 3 squared, which is 9. Then my first term is a times 2 times 5. And my other 2 terms go away because they both have an x minus 3 factor. And when x equals negative 2, I get 4 equals, first term goes away, second term goes away, the third term is c times negative 5 times negative 3. So that worked out nicely. So b is negative 1/6. C is, oops, let's see, a is 9/10. And c is 4/15. So I've got my a, b, and c, and then I'm just going to plug them in here. B is negative 1/6, and c is 4/15. And then I'm going to integrate term by term. So to integrate this, I integrate this whole thing. And I integrate each fraction separately. So I'm going to get negative 1/6. I'll write it down again. Maybe I'll make a copy. Okay, so this becomes negative 1/6, the ln of x minus 3. These were not both negative 1/6. I messed up. A was 9/10. Okay, 9/10 ln of x minus 3 minus 1/6, the ln of x minus 1, plus 4/15, the ln of x plus 2, plus c.